Hello, Cahit Barkazar from Çukurova University Computer Engineering Department, 4th grade. Today I will talk about RBF, Radial Basis Function. So scientists, when trying to do classification like this, they had to calculate a multi-linear, non-linear models, and that took longer, as you can see, but they wanted to find a faster, easier, simpler model. So they did mapping and they used radial basis or sigmoid polynomial to create a, change its dimensions and find a more linear model to classify these values. And radial basis was one of them. I will show you the formula. This is the formula. It uses Euclidean distance, and for that it uses the centroids, and we are going to use k-means to find centroids, and r means the centroids, and the data's distance, diameter. And as you can see, it looks similar to the Gaussian model. So I will use RBF neural network. It has bases, works like activation functions, and then does its calculations, and then uses backpropagation to update weights and biases. And I'm going to show you the example. As you can see, this is exactly the same of this formula. And then k-means, I'm not going to explain k-means. You can watch my k-means video. But here this gets one directional input array, and then returns the cj, which is the centroid. And RBFNet, this is the heart of the code. So as you can see from the constructor, number of bases, learning rate, epochs, and RBF model, and infer STDs, which means if it's true, we will use the standard deviation of our data. If it's false, we will calculate our standard deviation and force all bases to use the same standard deviation. So all use the same standard, or it calculates its own standard deviation. So this is training, and then backpropagation. Forward pass, it does calculation, comes here error, and then goes backpropagation, it finds error and backpropagation, and printing the loss at the end. And prediction here also, we are going to use NumPy and Matplotlib here. I will use 3 samples and different hyperparameters to see the results. So we will use a random sinusoidal input and add random noise to it. And in this one we are using 2 bases, so 2 neurons here in this hidden layer. You can think like that, and it creates 0.14 and creates this. It's not really bad, but I want to try something else, so I made it 4. So there are 4 neurons here. It's more complex. If the data is more complex, you need to make a model more smarter, more complex. But loss is low, but as you can see, it is not very sinusoidal. On the other hand, this is sinusoidal, but the loss is higher because of these areas at the end. And the thing I changed was infer STDs. So I forced every neuron to use the standard deviation of initial value. And that's all. Thank you for listening.